Hello friends, how are you? I hope that you are enjoying the lectures and then you are getting some idea about the concepts of fundamentals of air pollution and then different terminology, the concept of chemical composition and then measurement of organic elemental carbon, other species, and then in this lecture, because in the previous lectures I told that I taught about the thermo-optical ECOC analyzer, in which there is a continuous measurement of transmittance which is usually used to calculate the split point between organic and elemental carbon. At the same time, this transmittance signal can also be used to calculate black carbon or equivalent black carbon if you just use the optical methods. So, in this lecture, because this calculation and this measurement of absorption include the Beer-Lambert's law, so we will discuss in this lecture what is the Beer-Lambert's law. Okay. So, Beer-Lambert's law is a sort of has a wrong name, as I said that it is postulated by two scientists rather, Pierre Bauger, and he was an astronomer. He found out that the light is diminished as it passes through the atmosphere. So at that time in 1700, 1750, 60s, he has no idea that why actually the light is diminished when it passes through the atmosphere. Of course, now we understand that anything that is passing through the atmosphere and the radiation intensity of the solar light is actually diminished. We call it attenuation and absorption or scattering or different terminology, whatever you can depending on the composition of the atmosphere. So he was not having the idea, but then in the Lambert, who was a mathematician, he first proved that pi is irrational, and he also but he did not discuss anything about the absorption coefficient. So he also had no clue, although he had discussed actually little bit actually about this concept. And in about 1700 and then 1863, so about 150 years later, August Beer, he added absorption coefficient and he related to the concentration in the solution. So actually the name that should have been there, Beer, Lambert, Bauger. This actually is three names, but the very famous actually it becomes Beer Lambert because they postulated and then they put the equations together. Although Bauger, Pierre Bauger, he discovered that the light is diminished, but he has no proof that why it is diminishing, and he was not able to give any idea about this one. So the way it is written, this is the equation, and then here you note there are different terminologies that are used here. A is actually absorbance, I1 and I0 are intensities. So this is actually initial or incident, we generally call it incident. You have to remember that it is called intensity of initial or incident solar radiation, and then this I1 is very important here. So okay, we'll come back to this one. So suppose there is actually some solution here. Let's discuss about the solution and then we will come back to the atmosphere part. This solution, this has some solution, and which light is incident, and when I say the intensity of the solar say any I0 of a wavelength, say h nu, or having a wavelength lambda is incident on this one, and this solution has a peculiarity to absorb or has a species that absorbs at lambda wavelength. So what will happen once this go? This will be three things that can happen. So just remember this one, either inside this one there will be kind of absorption, then this light is actually transmitted, and then this is actually incidence, and then one more thing that is there here is actually scattering. So whatever the species that is there here, it can do these three processes limited to this one. Okay. So you have either it will reflect, let's not go discuss about the reflection here, but it will be actually like scattering, and then transmission, and then absorption by the particle itself. Now usually there are too many confusions in this one. Okay, when I say absorption, so absorption, transmission and scattering, these three are actually physical phenomena. These are physical phenomena which describe, okay, to describe this process of scattering or transmission and absorption. Okay, when and because it is a physical phenomena, so there must be a physical quantity to measure this one. Okay, to measure this, whether it is more absorption or scattering or more transmissions, there will be actually different phenomena with this one. So the way it is defined, the process of absorption, okay, so this is actually kind of physical phenomena, and process of absorption lead to will provide, it will be measured by the term is called absorbance. Just be clear here, it is absorbance. Okay, and then if you measure how much is actually transmission, the formula is actually transmittance. Okay, absorbance and transmittance. And most of the time what we do when we are dealing with this kind of solutions, we are dealing with dilute solutions, and one of the assumption is that it is actually no scattering. So scattering is not there. If there is a scattering, then you have to correct for that one. So we will see that how it can be corrected, but usually this is the terminology that is used. And then the process by which the light intensity decreases is called extinction. Okay, I hope it is clear now. So extinction is a process through which we understand that there is a decrease in the intensity of the light as it passes through the medium or some solution, and extinction is actually sum of both the process absorption plus scattering. Okay, so now you remember this one, and these things we will come to, but just because we are discussing here, this will be given by absorption coefficient, this will be given by scattering coefficients, usually written as B within the subscript SAAT, and this is written BABS. Okay, and then extinction is written as B small ext. So BEXT will be BABS plus B scat. Okay. Now remember, what will be this unit? These are measured actually, these are scattering coefficients, and unit, all these will have a unit of million meter inverse. So just remember, otherwise it will be too much confusing here. So, and 1 million meter inverse is actually 10 to the power minus 6 meter inverse. Just remember this one. So somehow or another it is related to the thickness of the atmosphere. Okay. So if you have more thickness and light passes through the more thick atmosphere, there will be more extinction of light. Okay, and we will come to the equations later. I hope this is clear. Okay. Now, another very important thing is here, the way transmittance and then absorbance is defined. Transmittance is defined by intensity of transmitted radiation to the intensity of incident radiation, ratio of intensity of the transmittance radiation to the incidence radiation, but absorbance is defined minus log of transmittance. So, if I just put this capital T, transmittance, so absorbance is defined as minus log of transmittance, or you can write actually log of I0 upon I, or you can also like minus log of I upon I0. Remember here you have to put minus sign here, because I is generally less than I0. So, this means I upon I0, this will be less than 1, less than 1, sorry, and log of any number which is less than 1 will give you negative. So, that negative and here the negative signal will make it positive, or if you just put log of I0 upon I0 is more than I, so this means this number will be more than 1, and then you will have a positive value. So, this is defined as absorbance. This is very important. Okay. One more thing. So, if somebody asks you what is the unit of absorbance, so this is actually unit less, because this is ratio of log of ratio of the two physical quantities which have the same unit. So, log, you can take log of any number if it does not have any kind of unit. So, in a way these two have the same units. So, in principle although units cannot be cancelled, but in a way you can imagine that because you are dividing with the same unit, so unit is not there. So, log, this will be purely a number, okay, and this number you can take the log. So, absorbance will have no unit. Similarly, transmittance will also have no unit. Okay, and how it is related? So, the Beer-Lambert's law says that A is proportional to C concentration and A is proportional to the length. Okay, concentration and length, and length is usually called path length usually. Okay. So, you have from this actually if you just remove the proportionality, you can write A is equals to epsilon CL. Okay. And since we also know that this from this equation here, that A is equals to minus of log of I upon I0. Okay. So, what you can write is equals to epsilon CL. You can write I is equals to, you just remove the minus sign from here, you make it positive, this will be negative sign here, and when this will be negative sign, you take log, so it will be anti-log, so exponential of minus epsilon CL, okay, and you have I here, so it will be I0. So, it can be written as I is equals to I0 e to the power minus ECL. So, actually you have equations like I is equals to I0 exponential minus epsilon CL. So, now you can imagine that this is what is happening. This is the intensity that is passing through the solution after passing through the solution. So, when it is passed through the solution, the intensity will decrease, and this is the initial intensity of the incident radiation. So, this is actually, you can imagine that is actually constant in when it is incident at that time t is equals to 0, and then it is decreasing exponentially. This is also called proportionality constant. So, this is again a constant, and then with the concentration and with the path length. So, if you are having more concentration, your intensity will be decreasing much faster, or if you are having more, if the light is passing through more of the solar radiation, more path length, then your intensity will be negative. So sorry, the deterioration or the reduction in the intensity will be much higher. So the way if you just plot this equation, sorry I don't have space here. So if you just write here I, and this will be like exponentially it will be decreasing, something like that. Okay. So now to sum up, this is I said that it is actually should be called Beer-Lambert-Bauger law or Beer-Lambert law or Beer-Bauger law, but usually because the Beer was who promoted, who put the equation, and he reported that the absorption or absorbance is proportional to the concentration and path length, so he was given the name. So Beer's law actually relates to the absorption of light. Now you remember, absorption, I said this is a process, okay, it is not the measurement, and when we measure this value, how this process, the physical process, and when you measure this quantify, then you have absorbance, okay, usually written by capital A or sometimes small a, usually capital A is better, okay. So it relates to the absorption of light to the material the light is travelling through a medium. Whenever the light is travelling through the medium and the material that is there in the medium itself, and how much absorption will be there, it is dependent on the material itself, and then this actually, and the law states that there is a logarithmic dependence between transmission or transmittivity. This is C is actually. This is actually written transmittance, but this is transmission is not correct. Either you write transmittivity or you write transmittance of the light through the substance and the product of absorption coefficient of the substance and the distance of the light travels through this material. So path length actually, and then between the transmission of the light through the substance and product of absorption coefficient. So you can see the relation that A is equals to where is this? A is equals to epsilon CL, okay, and then A is equals to minus log of transmittance, which is actually log of I0 upon I, okay, because transmittance is I upon I0, and then you can write epsilon CL. These are the equations that are there. So L is the path length, C is the concentration, and epsilon is the proportionality constant, that is also called sometimes absorptivity. Okay. Now imagine a condition, I think I have or not, yeah. So in these equations, you see I derived these equations for you. Epsilon I0 is equals to I e exponential of minus epsilon L into C, or A is equals to minus log of I0, I upon I0 is equals to epsilon LC. So epsilon is the proportionality constant, and then it is called molar absorptivity. The unit is mole per centimeter or liter per mole per centimeter. This is very important here again. I must emphasize here that, so this is this equation. In this equation we have A is equals to epsilon CL. I say this is actually is called absorptivity. Okay, but assume a condition. Let's say that condition when C is equals to 1 molar, okay, and then path length is 1 centimeter. Now one thing you have to also consider here, it is sometimes science is or the equations are written that you have to follow. I mean, there is no very hard and fast rule. The way it is defined, mole is concentration for the SI unit and centimeter is for the CGS unit. And we have been taught that you are writing the equations, your unit should be either in the SI, all the units, or all should be in the CGS. But this is one of the exceptions where actually you use different units here. You don't, for example, for path length, you don't use meter here, you use only centimeter. Okay, so if sometimes if the path length is given in meter or millimeter, you have to remember, you have to convert it into a centimeter, then only you will get the correct result, otherwise you will not get the correct result. So this is one of the very big problem here. So okay, let's come back to again, sorry, we get disturbed in the three things. So when C and L is 1 with the respective units, A will becomes to epsilon. Okay, now when A is equals to epsilon, what does it mean? When A is equals to epsilon means the absorption becomes absorptivity. So absorbance of a solution, absorbance, you can define this one, absorbance of 1 molar solution and path length 1 centimeter. So this will be called as molar absorptivity. Okay, now again you remember I said that this concentration is molar, or actually you can say what is this, molar is actually mole per liter, L is actually centimeter. So what will be the unit of epsilon? We know that A has no unit, or this is unitless. So the unit of epsilon will be 1 upon, or you can say capital M centimeter, and this will give rise to per mole per centimeter, or it can also be, if you are writing 1 upon mole per liter into centimeter, and this will give rise to, what will it will write to, sorry, so liter inverse is here, so it will go up, it will be liter, and it will have per mole and per centimeter. So the unit of molar absorptivity is liter per mole per centimeter or per molar per centimeter. So just remember these things. Again I must say that if the units are given in gram per liter, you have to convert it to, for example, if the concentration unit is actually, it is given in, concentration is given in gram per liter or gram per ml, you have to first convert this unit into which, mole per liter. If you don't convert, your equations will be wrong, and if the unit of L is not in cc, you have to first convert it into cc, then only these equations you can calculate and use. Yeah, so I think I have discussed this one, the same things, proportionality constants, or you see here sometimes they have also written liter per gram per centimeter, because this is where the confusion starts. Okay, so the unit of, if the concentration are mole per liter, then absorptivity becomes molar absorptivity, and this equations you can reduce. This I have been telling, A is equals to epsilon CL, yeah, BC they write here, minus log of transmittance is equals to minus log of I upon I0 or log of I upon I0 upon I. So this is the very fundamental and very important equations. This please consider this one and try to understand this one. One way you can also write that, because I know that A is equals to minus log of transmittance and if I just like, I can write minus log of, okay, t is usually given because t number is very small, it is in the fraction. So, t is usually written in the terms of percentage transmittance, means whatever t is there, it has to multiply by 100. So, if you just write this one, usually they are written minus log 100 times t, okay, because t is very small, it is a number less than 1. So, this will be there, and this will be actually minus log of 100 per 100 sorry, when you have to write this unit actually in percentage t, then you have to divide t by 100 actually, okay. So, you have to divide t by 100. So, this usually it is transmittance is given by t by 100 because it is small. So, you can write this as a percentage transmittance, and percentage transmittance means you have to multiply by this one 100. So, these equations will become a is equals to minus log t and minus log t upon 100 actually you should write, okay, and then you can write minus log of transmittance plus log of 100. So, you can write this actually 2 minus log of, this will be actually percentage now, if the value is, if I write this one percentage t upon 100, okay. So, this will be minus log 2 log 100 means 2 and minus log of percentage transmittance, this will be there actually. So, you can calculate equations like this. This is actually most commonly used equations. The other equations are there, but they are not very commonly used. So, I have defined transmittance is I upon I0, percentage transmittance is transmittance into 100. So, you can just calculate this I upon I0 will be, this I upon I0 can be written as percentage transmittance by 100, and that is what we have used here. Okay, if you have to convert it to this percentage transmittance, so you just put this one, okay. Actually here percentage will be there, and A is equals to minus log t, you can calculate. So, usually what is people ask, this is a very simple question that is asked, if transmittance is 100%, remember if transmittance is 100% or t is equals to 1, what will be your absorbance? So, if transmittance is 1, from these equations, if t is 1, then A is equals to minus log of transmittance, and transmittance is 1 and log 1 is 0. So, absorbance will be 0. So, you can just understand by the concept that when all the lights are transmittance, okay, 100% transmittance means all the lights are transmittance. This means in that case what? There will be no absorption, this is simple. But when actually this is very confusing, people ask if the transmittance is 10%, what will be the absorbance? So, usually we remember, okay, if transmittance is 1%, if transmittance is 10%, then what will be the absorbance? So, usually people do not put these numbers in equation, they say that 90%, which is wrong, because transmittance and absorbance they are related with A is equals to 2 minus log of percentage t. Just remember, if this equation you have to use, if the transmittance is given in the percentage, then you use this equation, okay, and usually it is given in percentage, for example 10% transmittance. So, it will be 2 minus log of percentage transmittance is 10% is transmittance, 2 minus 1 is equals to 1. Now, when this is another confusion. So, when transmittance is 10%, absorbance is not 90%, absorbance is 1, but usually what we say that absorbance is 90%. So, just remember this one, that when the transmittance is 10%, absorbance is not 90%, absorption is 90%, you can say that. Absorption is 90%, only 10% light is transmitted, but only 90% light is absorbed. but because the light absorption, if you are asked that what is absorbance, then you have to say 1. If somebody asks that what is the absorption, then it will be 90%. So absorption and absorbance, I think I have made it clear, they are very different. Absorption is a process, and to quantify this absorption, we usually refer to absorbance. We don't refer to the absorption number actually, 90% or something like that. So we have to calculate absorbance and transmittance. This is little bit confusing, and almost every NET examinations or CSIR examinations or any competitive examinations, you will have at least 1 or 2 questions from this one. So just remember and try to understand this concept. Okay, this is very important. So I think I will stop here and see you in the next lecture. Thank you. Bye bye.